So good evening everyone. I am Pawan Kumar Sakya, PhD scholar from IIT Kanpur. I am the TA for the course of Elements of Solar Energy Conversion. There will be two discussion hour for this course on Friday and Saturday. On Saturday the session will be taken by me at 6 p.m. to 7 p.m. So today we will discuss few topics like solar time, standard time, and after that we will discuss about the atmosphere. Okay, and then we will see some problems. Okay, so let's start with the first topic, that is solar time and standard time. So now I will discuss the solar time. So in earlier time when there were no watches, people tell or know about the time by saying the sun position. So at that time they have decided few points to decide the time, like solar noon. They have decided that when the sun is above their head, then that one is called the solar noon. All the other positions are like sunset and sunrise. So with these 3 points they have decided their time. So I will also write a few things. So earlier there were fixed points like solar noon, then the sunrise and sunset. So the sunrise when the sun is at the eastern hemisphere. Whereas when the sunset is called when so as we know that the earth revolves around the sun, not the sun move. Sun position is fixed. But in our discussion we think like or say like that sun is moving and assume that earth is fixed. So I'm talking in that term that sun is moving from east to west. But as you know that the sun is fixed. So So what happened at that time that by using these 3 points, they have decided a particular time. Then the time is called the solar time. So also the instrument that has been they designed at that time to calculate the solar time is called the sundial. So there are still few sundial mm, that has been in Delhi and Jaipur. They are still exist. Also, there were many more, but they are demolished. So you can also understand this sundial like when suppose this is an stick and that is at a horizontal plane, and when the sun is rising, then by seeing its shadow we can compute the time. When it is above it, there will be no shadow, and at that sun time. So by seeing this the shadow of this pole we can tell the time. So that was the main physics behind the solar time that they used in the earlier time. So now what we have watches. So this is the standard time. And why we have come to this standard time? Because in the solar time, as we know that sun position is different for different positions. So at a particular position you can fix a particular time range, but at different position there will be different time. That's why we come to a fixed time, and that is called standard time, that we can watch on our PC, mobiles, also in watches. That is fixed for every places in India. Okay. Also, there are different time zones changing with the country wise. So for the solar time in India, we have fixed a particular position, that is Prayagraj, and our IST, Indian Standard Time, is computed as per the standard time, as per the solar time of the Prayagraj. Okay. So that's all. Okay, so till now, if anyone have any doubt, then he or she can ask. Okay, so let's go forward. So
Excuse me,
now,
sir.
yeah, yeah, Rohit, say.
Sir, actually, sun direction is changed in yearly.
Yeah,
So how it made the solar time? But
yearly.
in December they are in east, they are in the south side, and in June, January,
Yes, yes,
June time is the it is west side. So their shadow is the different from month to month. It changes.
yes, that is correct. But at that time, it was not that much researched at that time. So there will be some uh, changes in the time, but they don't compute that error or that at the time. Okay.
Sir, in Jodhpur,
Yeah.
you said that there is a solar dial is mounted in Jodhpur. So
Okay.
how it works, sir, in Jodhpur?
How
Because
it
they
will
are
work in
in the same
Jodhpur?
condition, sir.
Uh, Rohit, I'm not getting your question. I have told you that
Uh,
there will be different time zone at different places. If we are on the solar
hmm,
time,
hmm,
so at every places there will be sunrise, solar noon, and then sunset.
hmm.
Okay. So still you have any
Uh,
doubt?
सर एक्चुअली मेरा क्वेश्चन ये था कि जो सन की पोजीशन है वो तो चेंज होती रहती है
Yes. With the year.
दिसंबर में नहीं दिसंबर टाइम में जो साउथ साइड में रहता है एंड इन जून टाइम जो थोड़ा नॉर्थ सॉरी वेस्ट साइड में रहता है
Okay.
तो,
Okay.
तो
Okay. So
जो शेडोज है वो तो चेंज होता चला जाता है
yes. Yes.
तो
So
टू मंथ सोलर डायल चेंज होता है क्या
yeah, that is correct. That is correct. So that I told you that they are not so much accurate at that time. Okay, that
ओके सर
that there are certain limits of that time. That's why we are using standard time.
ओके
Okay, okay. So let's move forward. So now we will see that how these are connected: solar time and standard time. So there is a formula that I'm writing. Solar time is equal to standard time. Plus okay. So by using this formula as for a particular country, that is like India, we have fixed the standard time as per the Prayagraj. So now at any place we can calculate the solar time using this formula, where the first I will discuss this plus minus term, why there is plus and minus. So this okay. So as we know that the uh, sun traverse around 1 degree in 4 minutes. So this one is using that concept. Also this LST and LOC is the longitude LST is for longitude for the standard position, and LLOC will be local, where you want to compute. Okay, and now what is E? So E is the factor called equation of time. So as Rohit has asked that what will happen when the time when the sun changes day by day, sun position. So that is the factor that has been included in this equation of time. That we can write E equal to 9.87 sine 2, where B is 360 and minus 81 divided by 365. And as we know that n is the number of day. As for 1st January, n will be first, n equal to 1. If we want to calculate for 25, then it will be 31 days in January plus 20th day of Feb. So it will be 51. Okay, so now from here we can see that the equation of time finally depends on the number of day, on which day we want to calculate the solar time. So that Rohit, now you are able to get your answer.
Yes, sir.
Yeah, at that time it was not
Thank you, sir.
included. Okay, now we have a standard time, so now there is a factor included, that is E. Okay, okay, so in this formula there is a plus and minus, that I want to say that plus is for western hemisphere and negative is for eastern hemisphere. What does that mean? That as we know that suppose this is our globe, and this is our prime meridian. Okay, as we know that this prime meridian is passed through the England. Okay, then what is about its east? Then it will be any place will be computed as taken with the negative sign. Okay, so when we will see this when will be plus and minus in next few problems. Okay, so is there any problem till now or any questions? Okay, fine. So let's move to the second problem. So the second problem is the calculate the solar time at Kolkata, and this is the location when the clock reads 6 p.m. IST is computed with reference to Prayagraj with these positions. Neglect the correction introduced by the equation of time. So in this problem, the formula I have given you. If you want to try, then you can try. I give you 1 minute, and you can post your answers, or you can unmute and let me know your answers. Okay, after if you are not able to solve, then I will do this problem. So this one is very simple problem. You can solve it in a minute. Also, so anyone has got any answer? Okay, fine. So now I will do that. So in the problem, the that is given that solar time at Kolkata is at Kolkata when the clock reads 6 p.m. the solar time at Kolkata has been asked, and what is given? The clock reads 6 p.m. As we know that the clock reads mean this is the same time that will not change with the position in a particular country. Okay, so it will be the standard time. Okay, so standard time, what will be it? 6 p.m. Okay. Also, the coordinates that is given for this particular place, that is 23° north and sorry, and 88° east. Okay, so what does that mean? 23° north. This one is the latitude angle, and this one, this 88 is the longitude. Okay, I expect that you have already know this, and not then I will show you with this figure. Okay, so suppose this is a globe, our Earth, and this is the equator plane. Okay, so suppose this is the place, this is prime meridian. Okay, so and this is the center of Earth, so let's say K and this is C. Then the projection of this point K on the equator plane, what the angle is made with this projection line, with this connecting to the location, that is called latitude angle, that is L, that is given 23°. Also it is given north, so it will be positive. As we have, as per convention, we take north positive, and towards south we take negative. Okay, and what does that 88 means? 88 means, suppose this is prime meridian, and so what will happen, that the projection of this prime meridian and this projection of the location on the equator plane, so this is the angle that is called longitude angle. Okay, so that this is given 88° east. Okay, so with these coordinates we can now solve our problem, as we know that the solar time is equal to standard time plus minus 4 LST minus LFC. Also, there is a term E, equation of time. In the problem, it is given that neglect the correction introduced by the equation of time. So we can easily neglect this term, and plus minus. So as we know that this one is on the eastern side, therefore we will take the negative sign. Okay. Then what is LST? LST is the standard longitude. So standard is the Prayagraj, and the standard longitude for the Prayagraj is 82°. So 82 minus, and for the Kolkata it is given 88° plus 0, and what is the standard time? Standard time is 6 p.m. Okay. Also, I forgot to tell you that this is the term in the formula, this 4 LST minus LOC, it will be in minutes. Okay, and this equation of term, this will also give you the answer in minutes. Okay, so the solar time will be 6 p.m. or 6 hour minus 4 into minus 6 minutes. Okay, so it will be 6 hour and 24 minutes of PM. Okay, so this will be the solar time for Kolkata. Okay, if anyone has any doubt, then he can ask. Okay, so let's move to the next problem, that is find the solar time for Kanpur and with the given coordinates on 6th August when the clock reads 5 p.m. IST is computed with reference to the Prayagraj and with the given coordinates. Okay, so in this problem it is not mentioned that we have to neglect this term in term equation of time. So we have to calculate this term E. That is the difference from the previous question. So the day is given 6th August. So first, for 6th August, first we have to calculate the N. What will be the N? Okay. So Jan, Feb, March, August. Okay. 31, 28. And 6 August. So when we will add all these, then we will get that N is equal to 280. Okay. So now we have to calculate E, and this is the formula that I have given. B equal to 360 N minus 81 divided by 360. With the help of B, we will be able to calculate the term E, equation of time. Okay. So B will be 360 N minus 81 divided by 365. N is 218 minus 81 divided by 365. So when we will solve this, we will get that B is equal to 135.123 degree. Okay. So now with the help of B, we can calculate the equation of time. E equal to 9.87 sin 2B minus 7.53 cos B minus 1.5 sin B. Okay. So when you will solve this, then you will get that E is equal to minus 5.59 minutes or minus 5.6 minutes. Okay. So now in the given problem, this we know that this one is our longitude. This one is for standard, so this will be the LST. This one will be the LOC. That as we have to calculate for compound. Okay, and all these two longitudes are in eastern side. Therefore, we will have to take negative sign in the formula. Okay. So the solar time will be standard time minus 4 time LST minus LOC plus E. So what is the standard time that we have to see? That this is given that clock reads 5 p.m. Clock mean, as I have also discussed earlier, that this clock means standard time. Okay. So standard time is 5 p.m. minus 4 LST is 82 minus 80 and E value is minus 5.6. These two values are in minutes. Okay. So it will be 5 hour and minus 8 minus 5.6. So these two values in minutes. Okay. So when you will solve, then you will get that solar time will be 4 hour and 46.4 minutes of PM. Okay. So if anyone has any doubt, then he can ask. So I think there is not any doubt. So let's move to the next topic. So till now we have seen that how can we calculate the solar time, or if the solar time is given, then how can we calculate the standard time. So now we will look into the atmosphere. So till now you have learned that what is the extraterrestrial radiation or solar constant. That we know that all these two terms are outside the atmosphere. So what is happening in the atmosphere, that we will see in next few minutes. Okay. So suppose this is our Earth surface. Then above the Earth, the first is called troposphere. That is around 7 kilometer to 20 kilometer. Okay. I'm as we know that the Earth radius is very large. That's why I'm making Earth surface like flat. But in reality, what you can understand that suppose this is our globe, then the atmosphere is like this. Okay. So the thickness of this atmosphere, that is not fixed. It varies from place to place. So at polar regions, the thickness is low, that is around 7 kilometer. For the troposphere, that will become around very near to the Earth. Okay, this one I have drawn the total atmosphere. This is the total thickness, and what is happening with this thickness, that I am drawing here. Okay, so this one is the troposphere. Up above this, mm, there will be stratosphere. Okay, its thickness above the Earth is around 50 kilometers. Okay, our ozone layer also lies just below the stratosphere. That will be come around this. Okay, above the stratosphere there will be mesosphere, and above it there will be ionosphere. Okay, so this is the upper limit of atmosphere. Okay, so now what when the sun ray comes, what is happening with this sun ray in the atmosphere, that we have to see. Okay, so now we will see that what is happening for the attenuated radiation that we receive on the Earth surface. So mainly there are two processes that happen in the atmosphere. Okay, so what are they? The first is absorption, and the second one is scattering. I hope that the term absorption, you will get that what is happening with the sun ray in the uh, atmosphere with the absorption mean. Okay, so absorption. So first I will discuss the absorption also. So what does that do? That because of this absorption, the sun ray intensity decreases. Okay, so as you have aware that the solar constant value, if we are taking that solar constant value 1367 watt per meter square is coming just outside the atmosphere, then it will reduce to around 1000 or 800, varies with the location of the position. As I have told you that atmosphere is not a complete sphere type. Its thickness varies place to place. Okay, suppose this is a distance d1 and this one is d2. Then it is not necessary that d1 will be equal to d2. There will be at some places there will be, the thickness of the atmosphere will be large. At some places the thickness of it will be lower. Therefore, there will be different intensity that we will receive on the Earth surface at different places. Okay. So the intensity decreases because of the absorption. Okay. Also, the major part of this absorption mm, is reduced by the ozone layer. So ozone layer plays a very important role to um, adjust the living of humans on the Earth surface. What does that do? That ozone layer, it absorbs most part of the UV radiation. As we know that the radiation wavelength come in the range of UV, then visible, and then infrared. So the ozone layer absorbs this UV part. Okay. So what we have receiving on the Earth surface, that is UV free, almost UV free. Okay. Also, this absorption is like spectrally selective. Okay, what does that mean? Spectrally selective mean that this absorption depends on the wavelength. Uh, with the wavelength changes, the absorption changes. As I have also told you that this ozone layer absorbs the UV part, not the visual part, because the UV part wavelength is different, that is lower than this visual part, and visual part is lower than this infrared. So the absorption occur behave differently for different wavelengths. Okay. Uh, so what are the gradients that are absorbing the solar radiation? So mainly there are water vapors, CO2 and ozone. Okay. So these are the gradients that plays important role for the absorption of the radiation. Okay. So now I will discuss what is the scattering. So scattering mean the change in the direction of solar radiation. Okay. So scattering is of two types: Rayleigh scattering and May scattering. Okay. Okay. So what is Rayleigh scattering? It changes the direction of solar radiation because of the small particles that is in the atmosphere. Also, this Rayleigh scattering depends on change the solar radiation intensity with the change in wavelength. That is spectrally selective. Okay. So it particularly changes the direction depending on the wavelength of lambda ki power minus 4. Thus, if the wavelength is lower, then the more scattering will occur. Okay. So therefore, small wavelength get affected strongly. Okay, so now I think you will know that as the Rayleigh scattering is because of small particles, thus the same will happen for the opposite to for the Bayes scattering, that will occur for because of the larger particles. So the water molecules, as these are the larger particles that had been in the atmosphere. Okay. Okay, so till now I have discussed the what is the process happening in the atmosphere. There are two processes, absorption and scattering. And scattering is of two types, that is Rayleigh scattering and Bayes scattering. Rayleigh scattering occurs because of the smaller particles like gases. These particles have lower dimensions, whereas water vapors, the dimension of it is larger. That is that therefore the Bayes scattering because of this gradients. Okay, so till now if anyone has any doubt, then he can ask. Okay, so let's move forward. So now I will discuss what is the air mass. Okay, so as I have discussed that what is happening with the atmosphere. Okay, till now I have not discussed that how it will affect with the time, that is from in the early morning to the evening. Okay, so we need some quantity to define that what is happening in the atmosphere with the time. Okay, therefore we have defined the air mass. Okay, so the air mass. Okay, so I think I have need to explain more with the figure. So suppose this is the horizontal plane at I have taken any position. Okay, and the sun ray in the morning, that is coming with some angle, that is alpha. Okay, then in the solar noon it will be above head. Okay, so we can see that suppose this is our observer O, and this is B, and this is C. Okay, so from this we can see that the light ray travels more when it is coming from this OB line. Okay, whereas in the solar noon it is just above our head. Okay, so therefore what is happening, that when it travels more in the atmosphere in the morning or evening, in the evening, suppose this is the in the evening. Okay, so in the morning and evening it is traveling more atmosphere. Okay, so its intensity will be different with the time. So that is why we are defining this air mass, that thus it's now I will write the definition. Okay, then you will get. So the air mass tells that the relative distance sun ray goes through the atmosphere with respect to the minimum distance. Okay, so it is denoted by m, and this m will be OB by OC. Okay. So from the figure we can see that the OC is minimum, or OC is lower than the above position. This is our minimum position or minimum distance. Therefore, the air mass value will be greater than 1. Okay, in the atmosphere. Okay, so when the sun is just above our head, that is at C position. So at solar noon, its value will be 1. Okay, okay. So now I will drive some formula for this air mass calculation. Okay, so from the figure we can see that the sun ray in the early morning makes some angle alpha. So this is the sun ray. Okay, so I hope that you are aware that what does this alpha mean. This is our altitude angle. Okay, and I think I need to make a new figure. So this is the horizontal plane and this is our vertical direction. Okay, and this is our sun at any position, and the sun ray is coming like this. So the angle that is making with the horizontal plane is called the altitude angle. Okay, and the sun ray angle that is making with the vertical direction is called the zenith angle, that is theta z. And this one is O, this one is P, and this one is C. Okay, so from the figure we have written that M is equal to OB by OC. Okay, but as we know that the earth surface is very large, that will be computed like the radius of the earth is around 6400 kilometers. Therefore from I have drawn this figure in very uh, short view, but in actual what will happen that this angle OCV, this will be around 90, as we will increase the curvature of this atmosphere with the radius. Okay, so from the figure we can see that this angle is theta z. Okay, so now I have to relate this OB and OC in this triangle. So this, then we can write that M will be equal to 1 upon cos theta z. Okay, cos theta z will be OC divided by OB in a triangle OCB. Okay, therefore we can write like this. Also we can say that it will be equal to sec theta z. Okay, so also we know that the alpha plus theta z, that is equal to pi by 2. The sum, as both the angles lie in a same vertical plane, that's why. So we can replace this theta z equal to pi by 2 minus alpha. Then we can calculate M is equal to 1 upon sin alpha, or we can write it as cosec alpha. Okay, so this formula I have written in terms of altitude and zenith angle, that I have considered that it will be pure 90 degree, but in actual it is not exactly 90 degree, it will be around 90. So it will be 1 or 2 degree or maybe lower angle, but so we can say that it will be uh, not exactly 90. Okay, so I think I should use this sign. Okay, Okay, so that's all for the air mass calculation. Okay, so if anyone has any doubt, then you can ask me, else I will move forward. Okay, so let's go to some problems. Okay, so this is the problem. Imagine yourself to be enjoying at a beach and you need to look up by 30 degrees from the horizontal plane to see the sun. Then what would be the air mass at that moment? So suppose this is our surface and this is our horizontal plane. Okay, this is our atmosphere. Then what the problem is saying that you are on this point. Suppose the point is C, and the sun ray you need to look up by 30 degree from the horizontal plane. So this, if this is the sun, then you have to look up. You are standing at this position and you have to look up at 30 degree. Okay, so now I think you have gotten that what does that 30 degree mean. So it will be the altitude angle that is given in the problem, and if we know that the altitude angle is 30 degree, then it is very easy to solve this air mass ratio. So m will be equal to 1 upon sine alpha, that will be 1 upon sine 30 degree, thus the m will be 2. Okay, okay, fine. So till now anyone has any doubt? Okay, so let's move to the next problem. Next problem is, what do we mean by AM0, AM1 and AM1.5? Okay, so I have told you that the air mass ratio m is greater than 1. This one is for in the atmosphere. Okay, because till now I have discussed that air mass is defined for the change in the solar radiation intensity. So outside the atmosphere, there is not any change in the solar radiation. So outside the atmosphere, that we can say that extraterrestrial. Okay, so outside the Earth, the air mass ratio will be 0. Okay, and what does that AM1? That I have also told you that when the sun is above our head, or it is traveling with the minimum distance, then it is called AM1. So what is AM 1.5? That I will discuss with the figure. Okay. So suppose this is the solar spectrum. Here the solar irradiance, and here it is wavelength. Okay. Then we know that this is the spectrum for the black body at the sun temperature. Okay, that is around 5800. Okay, on the earth, what is happening just above the earth. Okay, so this is the assumption that we consider. Okay, so I was saying that we have considered, or this is assumption that the sun temperature is just following the spectrum of a black body. Okay, because this is also the temperature of the sun is calculated with the varying temperature of the black body. When suppose this one is 5800, and we have plotted different spectrum for different black bodies like 6000, 5600. Then we have seen that at what temperature the sun spectrum is matching with this black body spectrum, and finally we have seen that the sun spectrum is well matched with the black body. Then we have selected this temperature 5800. That is not exactly 5800 Kelvin. There may be a slight variation. Okay. Okay. So as I have told you that there is nothing happen with the solar irradiation outside the Earth atmosphere. So suppose if we want to plot the solar spectrum just outside the atmosphere, then what will happen? That this is the spectrum that is well matched at the peak. Okay, then there is slightly variation, and then again at the larger wavelength it matches with very well with this black body spectrum. Okay, so this one is the spectrum at the extraterrestrial solar spectrum. Okay, now if we want to plot this AM1 and AM1.5, okay, spectrum, then we will see that in the atmosphere this spectrum, okay, so you will see that there are mm, very much changes in the spectrum as we come on the earth surface. So this is on the earth surface. Okay, from the figure also you can see that this spectrum is starting after certain limit, after certain wavelength. So this is our UV part. So this UV part is absorbed by the atmosphere. Also you can see that the solar maximum intensity that is reduced. That has been reduced largely. Okay. Also you can जब पता ही नहीं सब दोनों लोग देख रहे हैं 15-17 उन्हें बताया लेकिन नहीं तो नहीं देख रहा उन्हें क्या पता उन्हें तो नहीं पता. Also you can see that there are some large dips that because of the spectrum selective absorption. Okay, now this is I have drawn that is for AM1, that is the minimum distance that sun ray travels. Okay, then what AM 1.5, what will happen that this spectrum will fall more below with this spectrum. Okay, so this is AM 1.5. So from the figure we can see that as the air mass ratio increases, the solar spectrum or its peak maximum peak also decreases with the uh, distance that is traveling in the atmosphere. Okay, so that's all for today. If anyone has any question, then he can ask. Also, if you have any questions still remaining and if you want to ask later, then you can write me a mail, or you can ask any problem on forum. Okay, so this is my mail ID. Also, if you want to rewatch in these record these discussion hours, then it will be available on YouTube, and the YouTube link will be shared with you by tomorrow on the portal. Okay, so that's all. Thank you for the attention. Thank you.
Thank you, sir. Thank you.
Yeah, thank you.
Thank you, sir.